Dear students, we are discussing the subject of the elements of the civil engineering with you. In this topic of the different topics we are discussing with you in the subject of the elements of the civil engineering. All the basic aspects of the civil engineering we are discussing. We have started the discussion of the topic of the building construction in our lecture of the building construction 1. In continuation to that, today we are discussing the further topics pertaining to the building construction. Building construction is a very important job of a civil engineer. This is a very important structure which a civil engineering is concerned with. In the first lecture, we have discussed some basic things relating to the building. What is a building? Types of the building we have started discussing. In the previous lecture, we have already discussed the different buildings according to their utilization or the purpose. In the second category of the buildings, we have started discussing regarding the type of the structure. There are three ways in which a building can be classified according to the type of the structure. The first way of classifying that one is the load-bearing structure. The second is the frame structure, and third is the composite structure. The first two types of the buildings we have already discussed in the previous lecture. In continuation to that, today we will start our discussion with the composite structure. Let us see what is a composite structure is. As the name suggests, it is a composition of the earlier two. A composite of the load bearing and the frame structure where load is transmitted by columns and the walls. This type of the structure in which the transfer of the load is transmitted by the columns as well as that of the walls. Now let us see where this type of the buildings are preferred. This type of the buildings are preferred with the large span, like workshops or the halls, etc. If this type of the buildings with the large span is to be constructed, composite structure will be useful. In the composite structure, columns are also transmitting the load, but apart from the column, you are transmitting the load with the walls also. So therefore, the load is reasonably distributed among the columns and the walls. So, in the case of the larger workshops, composite structures are constructed. Here is one picture which you are seeing is an example of a composite structure. Here you can see the different components like the slab and the beam, an RCC column, as well as a load-bearing brick wall. The flooring is also mentioned here, and at the bottom you can see the foundation. This load of this structure is transmitted to the foundation by the walls as well as that of the column. So all the three vertical elements which is present there in the structure, that is wall and the column, they are responsible for the transmission of the load. So comparison between the load bearing and the frame structure we will now discuss. Earlier we have seen two categories of the type of the structure. One is the load bearing and another is the frame structure. Now let us see what is the difference between these two. In the load bearing structure, there is a components of the slab is there, beams is there, and the walls are there. In the frame structure, the components are the slabs is there, beams is there, and the columns are there. That is the difference. In the load bearing there is wall, in the frame structure there is a column. The load is transmitted through the walls in the load bearing structure, while in the case of the frame structure the load is transmitted through the columns. That is a basic difference. Looking to the wall is responsible for the transmission of the load. These load-bearing structures are limited up to a 3-story structure. The normal practice is that the load-bearing structures are constructed up to 3-story. And in case of the frame structure, you can construct a multi-storied building. So multi-storied buildings are constructed by using the method of the construction of the frame structure. In the load-bearing structure, the thickness of the walls reduced from the ground floor to the higher floor. The highest thickness will be there in the ground floor walls. As you go on the upper floor, the thickness of the wall is reduced. In the case of the frame structure, the thickness remains same. Walls are mere partition wall. In the frame structure, walls are there, but the function of this wall is not to take the load, but to just create a partition among the different rooms. So in the case of the frame structure, the wall thickness is remaining same. It is not changing. It is same for all the floor, and the walls have a purpose only for the partition. As you know that the thickness of the wall is getting reduced from the bottom to the top, the carpet area of the lower floor will be less. The carpet area of the lower floor will be less, and if you go on the upstairs, the carpet area will be a bit higher in case of the higher floors. In case of the frame structure, the carpet area is remaining same. In case of the load-bearing structure, the walls are constructed by the either it may be a bricks or a stone masonry. But in the case of the frame structure, the common material which is adopted is a RCC. So slab, beam and columns are constructed with the RCC. The construction time is more. In case of the load-bearing structure, the construction time is more and the cost is low and the life is less. Construction time is more, then the cost is low and the life is less. In the case of the frame structure, the construction time is less and the cost is high and the life is more. Life is more compared to the load-bearing structure in case of the this frame structure. So these are the discussion we have carried out relating to the buildings which is classified according to the type of construction. The difference between that load-bearing structure and the frame structure we have made. Now come to the next topic. The next point of discussion is the types of the loads acting on the buildings. Buildings are susceptible to be having a load from the different types. Let us see which are the different types of the loads which are acting on the buildings. First of all, the first load is known as the dead load. The second type of the load is the live load. Next is the wind load. Then is the snow load. Then is the load due to rain. And then last is the earthquake load. These are the different load or the forces. This is a list of the different forces which are acting on a building. The building is to be designed in such a way that it should resist these different loads which are acting on the building. Let us see that how these loads are acting on the building differently. First is the dead load. What is a dead load? Say for example, if a building is constructed, a building has its own weight. If nobody is there in the building may be empty, but the building has its own weight. The building has the weight of its own component. The load of the RCC slab, the load of the walls, the load of the other doors and windows. So first is the type of the load which is known as a dead load. This dead load is the permanent, immovable, untransferable load. Means it is a load of the building components. It is, in another way you may say, it is a load of the building itself. So this load is a load of the different material of which the building is constructed. So normally the dead load is the load of the different materials. So to work out or to know that what will be the load acting on the building, you must know the quantum of the material that is there in the building and this will be on the basis of the dimensions of the different components of the building constructed with the different material. That dimensions you must know. Then after you must know the volume of that particular material, and on the basis of that you can work out the load which is acting on the building. Let us see what is the unit weight of the different material that is being used for the construction. If you know this unit weight or the density of that material, you will be able to calculate the dead load. First is a sandstone. The sandstone has a weight of 2240 to 2400 kilograms per meter cube. This is a normal range of the unit weight of the different material. Then is a timber. The timber has a weight of 650 to 720 kilograms per meter cube. The bricks have a weight of 1600 to 1920 kilograms per meter cube. Then is the PCC. that is the plain cement concrete, that is 2300 kilograms per meter cube. Then is the RCC, that is 2400 kilograms per meter cube. Then is the steel, that is 7850 kilogram per meter cube. So depending on the type of the material, its different unit weights will be there. Steel is the most common type of the material, and it has a weight of 7850 kilogram per meter cube. RCC is also a very important material, and it has a weight of 2400 kilograms per meter cube. Some other materials is the cement, that is 1440 kilogram per meter cube. One is the sand, that is 1760 to 2000 kilogram per meter cube. Water has a unit weight of 1000 kilogram per meter cube. It will be useful for designing of the water tank. The clay will have a weight of 1760 kilogram per meter cube. Limestone has a weight of 2400 to 2640 kilograms per meter cube. These are the different unit weights of the different material, on the basis of which you can work out the dead load of the building. Then the second category of the load is the live load. Whatever the moving or the transferable load which is acting there in the building, say for example numbers of the persons visiting a building. You may bring some material, you may bring some furniture, movable furniture, you may bring some other house appliances. These all are the movable, transferable and temporary. Persons gathered in a house may disassemble. So this load comes and known as a live load. This is a movable, transferable, temporary and movable load. It is also known as superimposed load. This load is acting on a building on a temporary basis. It may be more, it may be less, depending on whatever the live load or whatever the things you gather in a building temporarily. This load is to be calculated according to the normal criterions are being there according to Indian standard. Say for example, in the design of a building, following types of the live loads are to be taken. First is the dwelling house. This is to be considered as a 200 kilograms per meter square. Then is the offices, 250 to 400 kg per meter square. Banks or the public buildings, it is 300 kilograms per meter square. Shops and the reading rooms, it is 400 kg per meter square. Workshop, it is 500 kg per meter square. Balconies, it is 300 to 500 kg per meter square. Floors of the warehouses of the medium height, it is 750 kg per meter square. And floor of the warehouses, factories and heavyweight, it is 1000 kg per meter square. These are the criteria to be provided for the live load. Now in the case of the multi-storied structure, when the number of the floors are more, say for example 10 floors are there or 7 floors are there, we know that all the floors will not be superimposed load at a time, because in the normal practice the load is not acting on all the floors at a time simultaneously together. Now, for that purpose, there is some reduction, percentage reduction in the load is suggested, because as all the floors are not to be loaded with the live load criteria that we have just discussed, for the sake of the economy, they are reduced, because in practical they will not have the load all the floors at a time. So number of the floor, depending on the numbers of the floor, the percentage reduction is suggested by the Indian standard. If it is a one floor, there is a 0% reduction, means in a one floor there is no reduction. If there is two floor, then there is a reduction of 10%. If there is three floor, then there is a reduction of the 20%. If there is 4 floor, then there is a reduction of 30%. If there is a 5 to 10 floors, then there is a reduction of 40%. And if there is about 10 floor, then there is a reduction of the 50%. So depending on the numbers of the floor, the percentage reduction is made. The next category of the load is the wind load. The wind load is normally acting on a multi-story building. The windward face of the building will have a force of the wind acting on that. If the height is more, the wind load will be a significant one, and therefore it is required to be considered in the design of a building. In case of the tall buildings, effect of the wind load is considered. The formula for finding the forces which is acting on the due to wind load on the building is mentioned here. It is P is equal to K into V square, where the P is the wind pressure which is measured in kilograms per meter square. Next is the K is the coefficient which is normally taken with the value 0.0006. And V is mentioning here is the velocity of the wind in kilometers per hour. This way the wind load is considered on a structure. In the mountainous and the northern India, there is another type of the load which is also considered, which is known as the load of the snow. Snow will have an effect of the load. When there is a snowfall, there are the buildings is susceptible to the snow load, and it is considered as a 2.5 kilogram per meter square of the area. The next load is very important, looking to the design of the construction of the building. Earthquake loads. Earthquake is a very prominent phenomenon, and the building should be designed as an earthquake resistant building. There are many measures are required to be taken so that the building should be earthquake resistant. A proper reinforcement, proper consideration of the forces, and the proper design of the foundation is very essential so that the building will be earthquake resistant. Depending on the height, depending on the width, the building is to be planned in such a way that it should be having a features of a earthquake resistant building. You may provide a reinforcement in the corner of the walls and many other measures. If you should not consider a slender building. You should not design a slender building. That is a necessity of a design of a earthquake resistant building. Due to earthquake, horizontal and vertical vibrations are created, and therefore the necessary earthquake factors are considered. Now, to take the considerations of these vibrations, it is necessary that the earthquake factors are to be considered. India is divided into the 5 zones of the earthquake to consider the forces according to the risk of the earthquake. This is a seismic map of a seismic zones of the India. This is a map of the seismic zones of the India. Different zones according to the Indian standard 1893-2002 is being shown here. The portion which is shown with the red color is indicating the areas where there is a more susceptibility or there is a more risk of the earthquake. In these areas, the necessary earthquake factors are to be considered and necessary measures are to be taken so that the vibrations of the earthquake will not damage the building. According to the different acceleration of the earthquake waves, the necessary factors are considered for the design of a building. For different types of the construction of the structure, it is very essential to consider the earthquake forces, and the structure should be designed in such a way that it should be an earthquake resistant one. These are the different loads that we have discussed so far. After discussing the different types of the loads which are acting on the building, now we will start our discussion with the building components. Let us see the building components. First of all, building has 2 main components, or you can say that there are 2 main parts of the building. One is the substructure or the foundation. Building is divided into the 2 parts. The very first one is the substructure or the foundation, and the second part is the superstructure. So building is divided into the 2 parts. One is the substructure and second is the superstructure. Let us see what is a substructure or the foundation. So substructure or the foundation. Substructure or the foundation is the lower portion of the building usually constructed below the ground level. So the building is divided into the 2 parts. One is the below the ground, one is above the ground. Substructure is the lowermost portion of the building. It is usually constructed below the ground level. The substructure is a part of the building below ground level. Now, this part of the building below the ground level, which transmit the load of the superstructure below the ground level. The function of this part is the transmission of the load of the superstructure to the ground. That is, that component, that part is known as the substructure or the foundation. Here is a picture which is mentioning the clear distinction between the substructure and the superstructure. Here you see the part which is there below the ground is known as a substructure, and the part which is there above the ground is the superstructure. Superstructure is the part of the structure which is above the ground level and which serves the purpose of its intended use. Now, the part of the structure which is above the ground, that is known as a superstructure. It may be a room, it may be a kitchen, or whatever may be the purpose for which it is being intended. That part is serving that purpose, and that is known as a superstructure. All the parts of the building that we see above the ground level is known as superstructure. Now, the superstructure has many different components. Here we have divided the building in two major parts. One is a substructure, another is the superstructure. Substructure is the foundation, and another all the components are the part of the superstructure. Superstructure's parts are: one is the plinth, next is the walls, columns and the beams, next is the ground floor and the upper floors, all the different floors, then is the sills, then is the lintels and weather sheds, then is the doors, windows and ventilators, then is the roofs and the slabs, then is the parapet, then is the stairs, then is the lifts, ramps, and the building finishes, which includes the plaster and the whitewashing. So all the parts are known as superstructure. Let us repeat this one once again. Plinth, then means the part of the building below the floor and above the ground, that is known as the plinth. Walls, columns, beams, floors, lintels, sills, weather sheds, doors, windows, ventilators, roofs, slabs, parapet, stairs, lifts and the ramps, building finishes. These all are the superstructure. Here we will see a typical wall section. Typical wall section. The different components of the wall section. At the bottom you can see the foundation. Now, the part of the wall which is above your ground and below the floor is known as a plinth. The plinth height mentioned here is 0.6 meter. Then the depth of the foundation is 0.9 meter. Width of the foundation is also 0.9 meter. Here you can see the details of the flooring. The tile flooring is given. Then after below that there is a brick bed cement concrete, and below that there is a sand or the muram. Then the slab is also mentioned here in this section. The part of the wall above the slab is known as the parapet wall. The height of the parapet wall here taken is 1 meter. On the top of the door which you see is the lintel, and the projected part which you are seeing is known as the chhaja part. All the dimensions of this are very important. The height of the door here taken is 2.1 meter. The ceiling height here taken is 3 meter. The height of parapet taken is 1 meter. Thickness of the slab which is mentioned here is 15 centimeter. Above the 15 centimeter slab, there is a 2.5 centimeter cement concrete layer is mentioned. These different dimensions are very important. The material of the construction is also mentioned in this section. The two parallel lines indicates inclined at 45 degree indicates the material of the brick. The dotted part with the different dots which is mentioned is indicating the reinforced cement concrete, that is the RCC is mentioned here also in the RCC slab or the lintel. The foundation here mentioned is a type of the spread footing. The width of the foundation at the bottom is 0.9 meter. At the bottom there is a base concrete is there which is having a thickness of the 0.3 meter. Then after the different steps of the footings of 0.6 meter, 0.5 meter, 0.4 meter is mentioned. The thickness of the wall is 0.3 meter. These are the different components. Here the substructure is mentioned, the superstructure is mentioned. All these different components are mentioned in this section. The study of this section of the wall is very important because there you will be able to understand all the normal dimensions of the building. Now let us see the foundation. Now let us see the different components of the building. Out of all the components of the building, foundations are very important because foundation is a structure which transmits the load from superstructure to substructure. The basic function of foundation is to transmit the dead loads, live loads, and other loads to the subsoil on which it rests. Various types of the foundations are used for different types of the structure. Now you see, the basic function of the foundation is to transmit the dead loads, live loads, and other loads to the subsoil on which it is resting. Various types of the foundations are used for different type of the structure. Let us see those various foundations. Foundations are broadly divided into the two categories. One category is the shallow foundation and another is a deep foundations. Depending on the depth of the foundation, the foundations are categorized as it may be a shallow foundation or it may be a deep foundation. First of all, let us see what is a shallow foundations. Shallow foundations. Depending on the depth. If the depth of the foundation is equal to or less than its width is called shallow foundation. Say for example, if the depth of the foundation is less than its width, then it is known as shallow foundation. Shallow foundation should be taken to a minimum depth of 800 millimeter. So when the depth is less than its width, then it is known as a shallow foundation. The normal depth of the foundation is near 800 millimeter. It may be extended up to 1000 millimeter also. So normally up to 1 meter you can have the shallow foundation. Now, where to provide the shallow foundation? In which situation it is preferable to provide a shallow foundation? If the hard strata is at a greater depth, it should be taken to such depth where soil has allowable bearing capacity. Now, in the case if you don't find the hard strata in the range of 800 to 1000 millimeter, you should go deep because the hard strata is required and the safe bearing capacity is also required for the safety of the foundation. Therefore, this depth may be extended wherever required, and where there is no availability of the hard strata within that much depth, you have to go for more depth. Shallow foundations are applied where the hard strata is available at relatively lower depths. Another type of the foundation is known as a deep foundations. Several types of the foundations are required for the different types of the structure. Normally, the open footing, spread footing, these are the different types of the foundations are common for the buildings. In case of the deep foundation, pile foundation, caisson and the cofferdams, this type of the different foundation structures are required to be well foundation is also one of the foundation for the bridges. When the depth of the foundation is equal to or greater than its width is called deep foundation. In this situation, the depth of the foundation is more than its width. If this is the situation where the depth is much, then it becomes a deep foundation. One of the common example of the deep foundation is a pile foundation. Pile foundation is the example of the deep foundation where loads are taken to low level by means of the vertical member. Piles are the vertical members that may be of reinforced cement concrete, or it may be of the wood or of the other steel material. These types of the piles are constructed. They are vertical member and they are transmitting the load of the structure at very depth of the soil strata. When the hard strata is not available at the shallow depth, hard strata is there at very big depth. In this situation, deep foundation is the option available. Let us see the different types of the shallow foundations. Which are the different foundations? Different types of the shallow foundations are: one is the spread footings. Spread footing, as the name suggests, the load of the wall is being spread by the expanding the base width. That is known as a spread footings. In the section which we have seen just earlier of the wall section, the foundation that what was mentioned there was an example of a spread footing. Another is the combined footing. Combined footing means there will be a common footing is to be provided for the different columns. Then is the different types of the shallow foundation is a strap footings. Strap beams are provided and this type of the footings are known as strap footings. The another type of the foundation is a mat or raft foundation. Mat or the raft foundation, sometimes in the entire foundation area at the bottom a common slab is constructed which is known as a raft. This type of the foundation is known as a mat or a raft foundation. First is the spread footings. The spread footings are those which spread the superimposed load of the wall or column over a large area. As the name suggests, the basic function of this foundation is to transmit the load of the wall over a larger area. That's why it is known as the spread footing. The spread footing is supporting either a column or a wall. This footing is supporting a column or a wall. Let us see the different types of the spread footings. Different types of the spread footings are: one is a single footing for the column. Single footing for the column. Second is the stepped footing for the columns. Third is the sloped footing for the trapezoidal for the column. It is a sloped footing or a trapezoidal for the column. Fourth is the wall footings without the step. Wall footings without the step. Next is the stepped footing for the wall. And next is the grillage foundation. Grillage foundations are common in the industrial sector. These are some basic types of the spread footings. These footings we will discuss. Here we are seeing a picture of a typical foundation of a wall. Let us see a typical cross-section of the foundations of the walls of the different thickness. It is either a 20 centimeter or it is a 30 centimeter. These foundations are the type of the spread footing. Here you see at the bottom of this there is a base concrete. Depending on the thickness of the wall, the dimensions of the base concrete will be different. Say for example, for the 20 centimeter wall, there is a width of 70 centimeter is required. For a 30 centimeter wall, there is a width of the 90 centimeter is required. Base concrete is made up of the cement concrete 1:4:8 or some other proportion. Brick masonry here mentioned will be having the dimensions of the different steps. The depth of the different step will be normally taken 10 centimeter and the width of the steps will be right from 60 centimeter or 50 centimeter or 40 centimeter and up to it will be reduced ultimately to the width of the 30 centimeter. This is a very typical example of the strap footing or the foundation of the wall for the different thickness of the wall. This is an example of a foundation for the wall thickness of the 40 centimeter. Here all the dimensions are mentioned are in the centimeters. The width of the foundation concrete is 110 centimeter. The thickness is 40 centimeter for the base concrete. This is similar to that what we have just seen of the foundations of the 20 and 30 centimeter wall thickness. Here you see that the load is being transferred from the wall into the different steps from the 40 centimeter to 50, 50 to 60, 60 to 70, and then it is transferred gradually to the base concrete, and the base concrete will transfer the load to the subsoil. So today we have discussed about the different types of the buildings according to the methods of construction. We have seen the method of construction, the composite structure. We have seen the difference between the load bearing and the frame structure. Today we have seen the different types of the loads which are acting on the building. Then also we have seen the different components of the building, and we have some foundations. We have discussed also about the foundations of the building. All the students, thank you very much.